Hello YouTube. I am Lewel Stamp, and this video is going to focus on the Mekanism reactor and the associated systems that are needed to feed it and keep it fed happily. This entire setup was built in a single chunk. As you can see, the outline of the sand that's somewhat 3 blocks down. That's the outline of the whole chunk. A friend of mine asked me to build it, and I did. Now, before we get started, I'd like to show you something that's going to become relevant very quickly. I'm standing on a advanced solar generator, and let's see. As you can see, it is producing 120 RF per tick. The sun is true. It's drained because it's outputting right now to a laser amplifier system that's sucking it dry. Anyway, so we're going to cover 5 of the 9 blocks of the generator, and you can see the sun is false. Now we're going to uncover one of them, and you can see that it is sun true, and it's max production, which means that you can cover less than half of it, and it will still work and produce full power. All right, so that is the solar advanced generators overlap, and this is why it's relevant. In order to get this to fit into a single chunk, these 3 solar evaporation towers have to have some overlap to them. It's like a step system. And you can space them further apart. They won't fit in a single chunk. No problem. These 2 are 18 high, and that one over there is not true to form, and I'll explain that in a minute. These 2 are water into brine. This one is -15 below ground level. This one is -16 blocks below ground level. They're both being fed by a series of pumps powered by advanced solar generators. We'll get back to that stuff in a little while. It's pretty simple and not very important to the system. But 1 block on any side will keep the entire thing in check and contained. So 1 block all the way around. Okay, so you can see that it's full of water. It's at a height of 18, multiplier to 3.5 thousand Kelvin. This one's identical, except it's 1 block lower into the ground. This system is the brine into lithium system, and it is not, it's only 5 blocks high with a multiplier of 2 and 9,000 Kelvin, but it's also full and feeding into this giant dynamic tank, which is just a buffer. It's mostly full. It's 12 blocks high, and with this being 5 blocks high, 17, it's 1 block lower, so it's the same footing as these 2. So they're both -16 below ground level. But anyway, the size of that dynamic tank, as I said, was 4x4 by 12, and it is more than plenty. It doesn't have to be that big. It's overkill. All right, so all of this feeds into a single rotary condensator, which is the arrows pointing to the left. It is producing liquid lithium into gaseous lithium. It's deconcentrating, I guess. And it does have some upgrades in it. It has 8 energy and 6 speed upgrades. Not terribly important, but I found it useful. All right, so this feeds the gaseous lithium into the bottom side of all of these guys, which are solar neutron activators. When we run this guy, in order for it to be fed in a single chunk, we're going to run it on an injection rate of 2, which is the minimum. 6 solar neutron activators are sufficient to feed it during the day, but at night it uses up stored tritium. And if 6 is perfect for the day, you figure double it and it would last through the night, but because of some weird internal math, it doesn't quite work that way. It uses about 1,000 millibuckets per 50 seconds at all, and so in the nighttime, I've just found it useful to do 13 instead of 12. That seems to keep it pretty stable. They're very expensive, by the way, so but let's see, 6 is good for the day. The nighttime is 546 seconds approximately, so 9 minutes and 6 seconds out of a 21-minute cycle, which is why you need it to be 13 and not 12. And this, of course, is in a desert biome, which limits the amount of rainfall, which would block the sun. Again, reason to have 13 instead of 12. Now, this is the huge bottleneck in the system. This is the place that if you want to keep it stable, it's better to go overboard than to to worry about materials and costs. Do 15, do 20, whatever. I found this fits. It doesn't block too much of the solar panels. It works out pretty well into a single chunk. All right, so on to the electric pump now and the deuterium system. We've covered tritium. This thing requires deuterium and tritium. Okay, so here's the electric pump system. Over there, I've got 7 feeding water to those guys, and here I have 5 feeding heavy water into this dynamic tank, which is full. The heavy water is produced in a regular electric pump with a filter upgrade installed. I will caution you that the water pumps are indistinguishable whether they have the filter upgrade or not when they're in your inventory. You cannot tell. So if you have a bunch of them in your inventory and you accidentally swap this one for that one when you're building the system, you'll flood this system with heavy water or vice versa, and then you've got to drain them. It's a big pain in the butt. So I recommend keeping them very separate when you're doing your build. All right, so anyway, this feeds into the dynamic tank here, which is a 4x4x4, which is more than adequate. And it comes out to this electrolytic separator, which I've got turned backwards. So the oxygen is coming out on the empty side here, right here, into a bunch of gas tanks. This gas tank is set to dumping excess, just in case I want to later use this oxygen here. That way it won't bog the system down and stall it. Right now it's stalled because this is full. So this is the deuterium coming out here. And as you can see, it's going into a series of gas tanks, which is kind of a complex mess, and I apologize for that. It makes more sense once you get to know the system of Mekanism. But basically, you can see that little notch on the side of the gas tank. That's the only output. So you can bring gas in from any side, top, bottom, or any of the 3 sides, and it will only output on that side. So it's coming into there, and it's running into this one, which is running directly into that one, which is going through a channel of pressurized tubing up to the top, which is then feeding into that one, feeding into this one, feeding into this one, feeding into this one, and then going into some more advanced pressurized tubing, or basic pressurized tubing, I'm sorry. Anyway, so this is a buffer system, much like the dynamic tanks are, but it's for gas. This one's doing the exact same thing for the tritium that's being produced by the solar neutron activators. It's coming down out of the series right there and going that way, down through here, and then out through here. Okay, very good. All right, so one electrolytic separator is good enough. Same with the rotary condensator. All right, so both of them are powered by this guy. It says basic energy cube. That's an ultimate energy cube, which I've charged over many, many, many days. That'll last, and that is all. As soon as the system gets full power, I'm going to change it out for a tesseract, because the goal of the build was to do it all with Mekanism, which I have done. But once the system is running, I'm going to need tesseracts to produce or to transfer the power where I want it. So that will change out for a tesseract. Anyway, so so that's the 2 types of gas. They're coming into a chemical infuser, which you can see has the deuterium on one side and the tritium on another side. It's not powered right now because I don't need power. If I did, I would just put a fuel cell underneath it. It would power it, and it would produce DT fuel. I have a gas tank right there that is, not filling up. Probably because it's not powered. Not sure why. Anyway, all I did was fill it up on that guy earlier. I guess it needs power to do it. Okay, so anyway, that's producing DT, which you need to charge your reactor with prior to ignition. So I'm going to show you that right here. There's the DT that I charged it with. There's the tritium coming in. There's the deuterium coming in. I charged it with a port right here. I put the gas tank on it like yeah, and then turned it around so that the output is facing in. That charges it. Then you can get rid of that. It goes back to normal. It'll be fully charged. Then it also needs this guy, which is a hull rum. Now if you put the gas tank down, you can put the hull rum right here and it will charge it and you're good to go. And then you install it there, charged, and then the reactor, fed by the two necessary gases and filled with DT as the charging supply and the hull rum, is now good to go. The injection rate here is 2. You can adjust it here. You can go up to 98. Won't go any higher than that. 98 will drain you of gas instantly, basically. 2 produces a ridiculous amount of power as it is. I wouldn't recommend going over that. Unless you just really, I'm not in the build craft. Excuse me, the build guild. I'm not in the build guild. I don't build huge things. This is supposed to be one chunk, and it is. All right, so the ignition of the reactor comes from a laser and a laser amplifier. I set this guy up, the solar advanced generator pumping into there. Takes forever if you use a single laser. It requires a lot of power. I've got this thing up to, I don't know, 400 million. It's at 405 million right now. It only needs 400 million to ignite the reactor to get it up to temperature. So it's ready to go. I charged it with this solar advanced generator and a series of energy cells. It took a long time. Okay, so that's the laser system. Now we'll talk about the induction matrix for just a second. That's this guy that I'm standing on. All right, as you can see, the induction matrix is a 4x4x4. It has 4 elite induction cells inside of it right now. It has an advanced induction provider and a basic induction provider. Those cells are all additive. These providers are also additive. So one of them produces like 25,000 RF per tick input output. The other one is 204, so they add together to be like 230 something. The hollow space is completely fine. Put it back together and it does its thing. This is a induction port, another induction port, another induction port, and as you can see, there's a reactor port on that side that is directly in line with an induction port directly adjacent to it. You don't need any cabling or hoses or anything like that to put the two together. You line up to 2 ports and it works perfectly. All right, so when this is all lit up and going, I'm going to put a tesseract on there, and that'll be how the power gets moved around. I did have this lit up earlier, and as you can see, it still has 63 million RF in it. That's a buffer of 500 million right there. And in no time at all, this guy was full of 102 giga RF, which is a ridiculous amount of power. I'll never be able to use it. I'll be able to sustain some RF tools, dimensions that are extremely expensive, and not have to worry about it ever. This thing is nuts, which is why I wanted to build it. Okay, so let's see what else there needs to be covered. No, I think that's pretty much it. What do you say we just light it up? Let's light it up. All right, I don't want to die here, so we're gonna set this guy. All right, it's at 405.36. Let's set it to max 405. I forgot what it was at. Hold on. 405. Let's do 450,000. Enter. All right, so at 405.45, This thing's gonna go off like a bucket of nails. And in the meantime, while we're waiting for that to happen, and there it goes. So never mind with that. Let's get over here and take a look at it. All right, the whole ROM was consumed. You can see the temperature, case temperature, 107, going down. That initial explosion is very hot. Plasma going down slightly. It's going to stabilize pretty close to where it is now. But as you can see, it's already producing millions of RF super, super fast. It's an extremely potent system. And that's on a rate of 2. 2 goes up to 98. All right. So this guy's already full. These guys will start feeding their system, the tritium, into the system now. And they'll go down, down, down. But these 13 should provide enough. It's going to drain from these 6 faster than it's going to drain from these 7. It's just the way that it goes. I don't know why. I can't really explain it, but that's how it works. All right, so that's the induction matrix. That's the full system as far as I can tell. There are just a couple other things I'd like to mention before we close this video out. And that thing takes forever, by the way. Okay, so the dynamic tanks. Let's just talk about these real quick. When I did the initial build, I had this dynamic tank here in a place where I didn't want it, where I ended up not wanting it. So I moved it. It was 1 block over further that direction, and I needed to move it 1 block towards me. So the total block count for this guy is 160 blocks. The dynamic tank is 160 blocks. It was basically full, and I was afraid I was going to lose everything. I ended up having to move 132 blocks out of 160, and I didn't lose any of the material contained within. I'm assuming because some of the blocks didn't move. So it very, very nice that did that. All right, so another thing is this stuff, the solar evaporation blocks are extremely expensive, so be very, very prepared for that. It takes 8 copper and 1 steel per block, and that basically means you need around 2576 copper. So pretty bad. I mean, it's super, super expensive. What else? So also, if you want to scale this system up and still have it fit in a single chunk, you can, raise the injection rate to 4, but you're going to have to move these 2 things down below. The induction matrix and the reactor are going to be having to be moved down lower so that you can expand this system. I was going with the minimum just because, but you still have a fair bit of area, all this area that can be used to power solar items, and since they can't be covered and be used, you'd have to move this stuff down below and just do all of the solar neutron activators above this. Well, I would just double it every time you double the injection rate. So 26 for an injection rate of 4. All right, and lastly, before I go, let's get into hover. This is the basic outline of the single chunk and where everything goes. And it worked for me. I hope it works for you. And thank you for watching this video.